you. Okay, so we are here today at confidence interval and T distribution. This is the things that we have covered previously under LU2, right? We are still in LU2, but today we talk about T distribution and confidence interval. Previously, these are all the subtopics that we have covered. Right, so let's have a look at what is confidence interval first. So this is the definition of confidence interval. It refers to interval estimate or the range. The range. When we say the range is, oh, okay. Norisha, later I will show the QR code. For those who just joined, I will show the QR code at the end of the class. Don't worry. Okay. So when we talk about confidence interval, you have to remember that it's something related to a range. When we say range is something from where to where, okay? Let's say from, when we say from X from 10 to 20, let's say, that is the range. Yeah? So let's say X, let's say from X between 10 to 20. So 10 is the lower limit, 20 is the upper limit. So when we say about range, when we talk about range, you have to know that there are two things that you have to take note: the lower limit, upper limit, and the whole thing is called range. Yeah. So this confidence interval is a range, or we can say also a pair of limits or bounds. Yeah, to indicate the range within which the parameter is estimated to be. Okay, when we talk about the mean of the height of a sample, from what to what, from where to where. So that is actually what is covered by confidence interval. So I mentioned just now, the normal value used by statisticians is 95%. That is the most common. But there are also other values like 90% or 99%. Okay. Right. So for example, if 95% confidence interval CI is calculated in such a way that under repeated sampling, it will contain the true population parameter 95% of the time. So meaning to say that the trueness, the accuracy of the mean, for example, it is like 95% true, something like that, okay? Because we cannot say that whatever measurement that we are dealing with, we cannot say it's 100% true. Because of course there would be always errors. For example, if you measure the height, for example, if I want to measure the height of a sample of 20 students, perhaps I might overlook the scale, things like that. So the error will always happen. So in science or in when you are doing experiment later, when you are measuring the diameter of, let's say you are a zoologist, right? So when you are measuring the diameter of zoology, the leg of the whatever the insects, for example, can. So there must be errors. There's nothing in the world is 100% accurate. Okay, so that's why in statistics we allow some amount or some room for errors. Okay, so that's why there is nothing 100% confidence interval. It's always some room for errors. Okay, so 95%. For example, whatever the measurement of the things, the trueness of the measurement, and where it goes to 5%. 5% is the error. Okay, we know that 100% is the total, and 5% is the error, the mistakes perhaps. Okay. Again, the same explanation. 95% is a measure of the confidence you have that the interval contains the true population parameters. So that's why it's called confidence. How much you are confident with the trueness of the parameter. Okay. So other values, as I mentioned just now, apart from 95%, statisticians also refer to 90% and 99%. Okay, it depends. Sometimes you may also, if let's say in your statistical analysis, if later you are doing research in your final year, you might want to analyze your data statistically. So you can, in your calculation, there are steps later, you can define what is your confidence interval. Maybe you want to say that the confidence interval that you want to refer is 95% or something like that. Okay. So another thing that you have to differentiate, just now I talked about confidence interval is refers to the range, right? So if you see, for example, the mean value, if you are, perhaps you come across before this, like when people say the mean value plus minus something, okay? Plus minus is actually the error is within from what to what, okay? So for example, the mean minus something is the lower limit, the mean plus something is the upper limit, okay? So interval is the range within which your sample statistic is estimated to approach the true population parameter. So another term is confidence level. Yeah? Confidence level is the probability that you are wrong or that the sampling error exceeds the confidence interval given. Okay, usually the 0.05 level is chosen. Okay, if let's say the confidence interval is 95%, right? I mean the range that you choose. So the confidence level, 0.05% is the confidence level, is the error that you subtract from the 95%, 95% just now. Okay, so that is the difference between these two terms. Yeah? Okay, why do we need confidence interval? As I mentioned just now, there's nothing accurate in whatever measurement. Yeah, sample mean is not a perfect estimate of population mean. We have to expect that there are errors, right? It is bound to be at least either a little bit too high or a little bit too low. Okay, so for the estimate of mean to be of value, one must have some idea of how precise it is. That is, how close to a mean is the estimate likely to be. So that's why, because of there's nothing accurate, what we can do is like to have an estimation. But when we do an estimation, we should know what is actually the range. It's not something that is just we say that, you know, like one blind value. There must be a range. Yeah. So that's what is the estimated value. Okay. An excellent way to specify the precision or estimation is to construct a confidence interval. Okay, so that's why confidence interval is needed. Okay, so when we want to measure confidence interval, given that we know the mean, right? Let's say we are investigating a sample, or perhaps any value, any parameter, right? So once we calculate the mean, so how are we going to calculate the confidence interval? Okay, so there are two conditions given. The first one, so this is the first case or the first scenario, when the population standard deviation is known. Okay, you know about standard deviation before, right? So when the population standard deviation is known, what is the steps? Okay. Another situation is, I just skip first, just to show you the things or the scope that you have to cover. We'll go through this after this one. Another situation is when the population standard deviation, when the population standard deviation is unknown. Okay, so there are two scenarios that you have to know or how to calculate the confidence interval. Okay, so let's go first to the first situation where the standard deviation of the population is known. Okay, so what are the things that you need to what are the things that you need to do in order to calculate the confidence interval? Okay. First, you have to find what's the sample mean. So you will be given a situation of whereby there is a sample and they are the data of the sample. So what you have to do is you have to calculate the mean of the sample. Okay, and then you have to find what's the Z value, okay, we have a look at it later, but just for you to go through first the steps, and you have to know what is the standard error of the mean. So these are the things that we have to find out in order to construct the confidence interval. So this is, if you see the expression here, the lower limit and upper limit, and this is the range. So this is the form of confidence interval that you need to construct, or you need to find out. So what you have to find out is the X bar here is the mean, and the Z multiplied with the standard deviation of the sample. Yeah, the Z, this is the sorry for this is the lower limit. Yeah, the whole thing here, X minus Z times by the standard deviation, and the upper limit is here. Okay, so what are the things that you have to find out during the steps here is the Z, okay, and also the standard deviation of the sample. Okay, so we have a look at it later. I'm sure that you are still wondering what is what of those things. Okay, so this is an example of a problem. Assume that the standard deviation of SPM verbal scores in a school system is known to be 100. So apparently it is given. This is the standard deviation of population. Okay, why I say it's a population? Because it is mentioned later that there is a sample. Okay, a researcher wishes to estimate the mean SPM verbal score and compute a 95% confidence interval from a random sample of 10 scores. So these are the 10 scores obtained from 10 students. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it shows here that the first iteration just now, right, SPM verbal score in a school system, that refers to a population because it's a school, right? So it's a big scope, right? And then it is mentioned that there is a random sample of 10 scores. So apparently the information before is given a population. So in this case, the standard deviation is known, right? So we have to apply the things that we have discussed as some of the steps, okay? But just go through first the information here. So the standard deviation is 100. The question asks you to compute 95% confidence interval. Okay, given to you a random sample of 10 scores. So the n of the sample is 10. So these are the scores of the 10 students in the sample. So what you have to find out is, step 1 is to calculate the mean and standard deviation of a sample. Okay, so how to calculate the mean is just, just find the average of this thing. Yeah, you plus 320 plus 380 plus 400 until 780 divide by 10, you will get 530. Okay, I don't have the workout here, but that is how, I mean, it's quite simple for that. Okay, the mean of the sample or the average. And we know that it's 10, it's given in the question. And we have to calculate the standard deviation of the sample. Okay, remember now, the first information given is the standard deviation of the population. We cannot use it directly because it refers to the population. So this is, remember, this is a formula that we discussed from last lecture, how to calculate the standard deviation of a sample, right? The standard deviation of the population divided by the square root of n, okay? So this is the final value, 31.62. This n should be small n, not big N. So mistake here. So this is the values of mean and the values of the standard deviation of the sample. Is it clear, guys? I just want to make sure that I don't talk alone and you guys can get my message. Okay, guys, is it clear?
Yes, doctor.
Okay, thank you. Thanks. Okay, thanks, people. Right, so this is the first step. So what is the second step that we have to find out? You have to find the Z value bound by the 95% confidence interval. So I just wrote the information from the previous step on the top of the slide. Yeah. Okay, how to find the Z value? Okay, now the 95% confidence interval. So this is actually what 95% confidence interval of the data looks like. So the whole data, right? So 95% sits in the middle. Okay, so that is how 95% of the distribution looks like. Okay, so what you have to find out is what is the Z value that that is bound by the 95%. Okay, so how to find that? So we know that the total area or the total percentage is 100%, right? So the total area under the curve is 1. Yeah? And when we convert the 95% into decimal points, that's 0.95, isn't it? So 0.95 sits in the middle here. So the error or 5% goes into both of the tiles on the left and on the right. So it's divided equally because this is symmetric, right? So that's how you get 5% is 0.05 divided by 2. So that's how you get 0.025 on the left tile and 0.025 on the right tile. Okay, so that's how the distribution looks like. Okay, so now knowing that the Z table, if you still remember the Z table, so we can just refer to the right side, isn't it? But it doesn't matter because it's actually symmetric. So now we just refer to the right side. Okay, here, in order to get the Z value. So 0.95 just now here, you divide it into 2, you will get 0.475 for each of the side. Okay, this is on the right side here, right? So this is the area from 0 to Z. Okay, and this is the tile area, the same, 0.025. So why we have to shade this area of 0.475? Because in the table, the Z value is given from 0, the area refers to when the Z value is this one lah. How to say that? Okay, let me rephrase. The area is given from 0 to whatever the Z value here, right? I mean 0.475. So that's why you cannot use 0.025 in order to find the Z value. Okay, so in order to find what's the Z value that corresponds to the area of 0.475, so you refer to the Z table. Remember the Z table? I have to show you the Z table again. I think you already know the Z table. So you have to find what is the Z value that corresponds to 0.475. And the answer given by the Z table, I think, if you have problem to know this, let me know. But I assume that you know already how to use the Z table. So the Z value is 1.96. Yeah, that corresponds to this. Is it clear? Do you know how to find the Z of 1.96? You still remember how to use the Z table?
Yes.
Okay, so I don't have to show how to use the Z table. Okay, so that's how you get the Z 1.96. Okay, so what is the next step? Okay, once you get the Z value, so you write it down 1.96, and you have to find what is the lower and upper limit. So remember, this is the formula of the confidence interval. X, the lower limit is X, the mean, yeah, the mean minus the Z multiplied by the standard deviation of the sample, right? And the upper limit is X bar plus the Z multiplied by the standard deviation of the sample. So the difference is only the minus or plus. Yeah? For the lower limit is minus, for the upper limit is plus. Okay. So you substitute the values into this expression. Okay. For the lower limit, 530 is the mean of the sample. Remember that you calculated in the first step. So the Z is 1.96. The standard deviation is 31.62. Standard deviation of the sample. Yeah? So you got the lower limit of 468.02. And for the upper limit is plus over here. So it's 591.98. Okay, so that's lower limit and upper limit. We're not done yet. So the last step is to write the confidence interval. So to write the confidence interval, you just substitute the whole lower limit here with the value that you got, right? So the mu is between 468.02 and 591.98. Okay, that refers to the now you are talking about this mu refers to the mean of the population, because the idea here is that we want to estimate the population based on the sample. Okay, so that's why here we use the symbol of mu, which is the mean of the population. Okay, so this is the final answer that you have to give, or you have to write at the end. Don't end up with just calculating the lower limit and upper limit like this. Okay, it's not yet complete. So this is the final answer. So what does it mean here? It means that we can be 95% certain, confident, or sure that the mean of SPM verbal scores in the school system, or the mean of the population, is between 468 and 592. Okay, so that's what it means by this confidence interval, 95% confidence interval. So for the final answer, you can just write 2 decimal points, and that would be enough. Okay, 2 decimal points. But if possible, do calculation or any calculation, especially when you are dealing with a set table or any table, because most of the tables, they use 4 decimal points in the values in the table. So during the calculation, please maintain all the 4 decimal points. Yeah, don't round up too soon or too early, because otherwise your final answer might not be that accurate, might be a little bit far from the actual values. Okay. Even if you put the final answer 4 decimal points, is fine. To me, it's fine because it doesn't matter that much. Okay. Any question for this? Is it clear, guys?
Very clear.
So let me clear.
Yeah.
Okay, so I just right. Thank you. I just summarize the steps. So this is what this is for calculating confidence interval when the population standard deviation is known, is given the value. So how to know whether it's known or unknown? Like in this question, it is given to you, but you have to analyze the problem. You have to know that, for example, here standard deviation of the SPM verbal score in the school system is 100. So because later the information given is referring to the sample, so apparently you know that that information of standard deviation is for the population, and because it is given, it is known. Yeah, so you know what's the value. So the steps, I just want to summarize again, just to make it clear to you. So normally the question will ask you to compute 95% confidence interval. So what you have to come up with is what is the range of the population mean, the mu tadi population mean. So you have to give what's the range of the population mean lah. So that's what is meant by when it said compute 95%. Compute, it can be 95%, it can be 99%, it depends on the question. Yeah? But in this question, it's 95%. But that's the thing that you have to do when you have to compute the confidence interval. So what you have to do first is calculate the mean, standard deviation of the sample. Yeah, this is the mean, is the average. Standard deviation of the sample is you use this formula. Okay, the standard deviation of the population divided by the square root of n. So you get the standard deviation of the sample. Okay, x bar is referring to the sample. Okay? So the second step is to find the z value. So how to find the z value is given is based on the question. If the question asks you 95%, so you have to sketch this 95%. So 95% of the data is in the middle. It's always like that. It doesn't, you know, there's nothing that goes to the right or goes to the right. It should be lies in the middle, 95%. Because it is symmetric. Okay, what you have to find out is the z value that corresponds to this 0.95 area lah. Okay, So knowing the rule of thumb that the total area is 1, okay, you know that the tile area 5% goes to both of the tiles. Okay, so you divide it equally. So in this case, the tile area is 0.025. Okay, so in order for you to use the Z table, you just refer to one side, right? And you have to know what is the area from 0 to the Z value. So 0.475, right? Because you divide 0.95 into 2. Okay, so this is one side only, 0.475, right? And you can see that the total here is 0.5. If you add 0.475 and 0.025, that's 0.5. Okay, so the total area of one side is always 0.5. Okay, so you find or you get the Z value. In this case is 1.96. Okay, make sure you know how to find the Z value. Okay, we have discussed it in the previous lecture. So once you get the Z value, you substitute into this formula. This is the formula for confidence interval for when the standard deviation of the population is known. Okay, so this is the standard deviation of the sample that you have calculated before. Okay, so you know already what's the Z value. Then you substitute into this expression, you get the lower limit, upper limit, right? And the final step is to write the confidence interval. The mu is between what? Okay, so make sure you use mu, not the X bar, because at the end we want to indicate what is the population, the mean of the population, from where it lies, from what to what. Okay, so this is the final answer that you have to provide if you were asked how to write or what is the confidence interval. Okay, so what is the difference? If let's say it's 99%, okay, 99% instead of 95%. So what are the things that you have to change in your calculation is that the tile area, okay? So let's say it's 99, so the total area here is 99. So here will be different. So 99, 0.99 divided by 2, that will be 0.99 divided by 2 is 0.495. So this will be different, okay? 0.495 for this one, and your Z will be different. Okay, the Z will be different. So what will be the different, or the next thing is the lower limit, because the Z here is different. If let's say it's 99%, okay? And the final answer would be different. It's a little bit, I mean, because of the distribution is wider, so the range is much bigger. That is what you can expect if the question asks you about 99%. Okay. All right. So that is the first part, calculating the confidence interval when the standard deviation of the population is known. Okay. The second part will be, okay, this is just what I said just now. I think it's covered here. Okay. The difference is the Z value and of course the range. Yeah, if you compare with the 95% just now, it's between 468 and 591. For 99%, it's wider because you see the distribution of the data is wider. So you can see it's from 448 to 611. So it's wider, the range. Okay. So these are the things of the formula that you have to find out. I mean, you have to use in this calculation. Lower limit, upper limit, and this is the format of the confidence interval. The assumptions is that the distribution is normal. Okay, standard deviation of the population is known, and the scores are sampled randomly and they are independent. So these are the assumption and the formulas that we can use for this first part. Okay. So I think it's clear. So we move on to the second scenario, when the population, when the standard deviation of the population is unknown. Okay, so how to know it is unknown? It is not given. The value is not given in the question. So you have to know by yourself that it is unknown. Okay. It is very seldom that we estimate the mean of a population when its standard deviation is already known. Therefore, the construction of the estimation of both. Okay. So this is the formula that we used previously when the standard deviation is known. Okay. But when the standard deviation is not known, so the formula that you have to use is instead of using the sigma, this is sigma, right? You use this as which refer to the standard estimated standard deviation or estimated standard deviation. Yeah, the symbol is as x equal to s. S is the standard deviation divided by square root of n. Okay, we're gonna have a look at how we calculate this later. Okay, and another thing that you have to take note in this case, when the standard deviation of the population is unknown, you don't use normal or Z distribution, but you have to use T distribution. Okay, T distribution. So this is another distribution or table that you have to refer. I think I have given to you in the Telegram, right? The T table. So perhaps you can refer to it for quick reference. I also uploaded it on edit, so you can refer and download it later, right? So just now we refer to Z table kan. So now we use T table in order to find the T value. So later we have a look at what is the T value that we are looking for. Okay. But just to introduce to you what is T distribution. So T distribution is used when the mean of the population is unknown, and also when the standard deviation of the population is unknown. Okay. In such cases, we use the sample standard deviation S to approximate the standard deviation of the population. The sampling distribution for X bar follows a new distribution called the T distribution. Okay, what is T distribution? T distribution is still normal. Normal is something that is like a bell shape. Yeah. But what is the difference? When we say normal, is anything is bell shape. But when we say Z distribution or standard normal distribution, is the one that when the mean is 0. Okay. In this case, you can see that the T distribution still exhibit normal or bell-shaped curves, right? So what is the difference between T distribution and Z distribution? For Z distribution, the mu is 0. So that's why you see the Z table is from 0, right? The values of 0 to Z, whatsoever the Z values. But for T distribution, what is also the difference is lower at the mean and higher at the tail. So you can see that the T is something that is below this. It's something that is flatter. It's much flatter. Dia kalau normal tu dia macam nampak macam normal. It's like higher the curve or the peak. But for T, the peak is lower. And it's called flatter lah. Bila dia macam lebih kepada base, it's called flatter than the normal. So that's one of the differences of T compared to normal standard distribution, standard or Z distribution. When we say normal, anything yang bell shape is normal, but the one that is with the mu equal to 0 is a Z distribution or standard normal. Yeah? As the sample size gets larger, the T distribution is a good approximation to the normal distribution. Okay, the T distribution is lower at the mean. You can see this is the mean, lower, and higher at the tails. The tails is higher, that's it, compared to the normal, standard normal. Okay, so that's about this is T distribution. The T distribution is used when the following conditions exist. When the standard deviation of the population is unknown and has to be estimated from the sample. when the sample size is more than 30, or when the population is normal or approximately normal. So this is the situations when the t distribution is used. Okay. So this is the observed t value. So Holland burst, we might not be using this t formula yet. Okay. This is the t table. If you refer to the attachment that I sent to you, what you have to find out later is the critical values of t, or we call it TC. Okay, so what is inside this t table? The first column here, you can see the degree of freedom, or DF, is given by the formula n minus 1, and is the sample of the size of the sample. Okay, and on the top row here is the upper tile area. Okay, so it's the same thing later when we refer to whatever the value of the confidence interval are. So we have to find what's the tile area. So that tile area is the one that you will refer to in order to find the t value needed. Okay, so here you can see the upper tile area is referring to the one side of the tile area. Okay, and the values in the middle here, inside here, is the TC, or the t value. Okay. Right, so still it's about this one. Okay, when we say the probability of the values is actually, it refers to the values from what TC to TC lah. This is just to show you how the T distribution looks like. What are the things that you need to know as well is margin of error. So margin of error, okay, let me just skip this one because actually it's referring to the whole thing here. Actually, this one there, this one. It's actually like the whole thing here. The whole thing here, when you calculate the upper limit and lower limit, whatever the value here is, that is actually the margin of error. Okay. We'll go back to the previous slide later just to see first what's the things after this. So this is the margin of error, the whole thing. Yeah. So you need the t value. The S is the estimated standard deviation, which you have to calculate. Yeah? And then N is the sample size. Let's say when you are asked, find the 95% confidence interval of a situation when the standard deviation of the population is not known. So this is the expression that you have to find out. So if it is x bar minus the whole thing here, that's the lower limit. The upper limit is the x bar plus the whole thing here. This is the margin of error. It's actually the same thing like what we studied for the previous one, the Z1 thing. Okay, this one you replace with a T, okay? And also this expression, this standard deviation. Okay, let's go directly to, okay, the whole thing here is E, yeah? So that's why you can see that the confidence interval, the form of the confidence interval is written with this. But E just now refers to the whole thing of the formula, yeah? Okay, let's go directly to a question just to show you clearly what does all this thing means. Yeah? So you can see actually it's here, T as X, the lower limit, the upper limit. Okay, so given to you this problem, a researcher was interested in estimating the mean reading speed of TESOL graduates and computing the 95% confidence interval. A sample of 6 graduates was taken and the reading speeds were 200, 240, 300, 410, 450, and 600. Assuming the samples came from normal distribution, compute the 95% confidence interval. Okay, so from this problem, you can see that unlike the previous problem, there is no information of standard deviation of the population. So from there, you know that the standard deviation is unknown. It's not given, it's unknown. Okay. and you are given a sample of 6 graduates here. So basically, you want to actually use the information from this sample to illustrate the confidence interval of the population mean. That's basically, it's the same thing like what I explained for the previous case. So you are analyzing the sample in order to give a picture about the population. Okay, so what are the things that you need to do? The first step, you have to calculate the mean. Estimated standard deviation. Okay, what is meant by estimated standard deviation? We have a look after this. And the degree of freedom, or DF, not DOF, DF. So the mean is quite simple. You just calculate 1, 2, 3, 4, 5, 6, 200 plus 240 plus 300 plus 410 plus 450 plus 600 divided by 6, because there are 6, right? And you get 366.67. That is the mean of the sample. Okay. Now we have to calculate the standard deviation of the sample. Okay, but because we do not know what is the standard deviation of the population, so what you have to do is you have to calculate the estimated standard deviation. So you have to apply this formula. This is the formula that you have to use. This is S square, which is variance, but you can find what's the S by finding the square root of S square. Yeah, but this is the formula that you have to use. Okay, how to use this is quite simple. X is referring to each of these. You know already what is the mean. The mean is 366.67. N is 6, right? So you just substitute. So 1 divided by, I don't have the full workout, but that's how you find it. Yeah? The sum of the square root of, no, the square of ni lah semua 366 sorry 200 minus 366 square plus 240 minus 366 square plus until 600, and then you multiply with this term. Okay, that's how you get S squared. S squared is variance, but you need S only, so you get the square root of this, you get the S value, and you substitute into this formula. Okay. And then the square root of n is 6 for the sample. So at the end, you will get 60.9736. Okay, that is the estimated standard deviation of the sample. Okay, because it's not given the population variable. That's why you have to calculate this in order to get S. Okay, degree of freedom, n minus 1, the formula. N is 6, x 6 minus 1 is 5. So you completed the first step. Okay. So the second step is, what you have to find out from the second step is to calculate the t. Okay, just now in the previous case, we calculate z, right? We find out what is z. So now this is t, and it is asked in the question that is 95%. So you sketch the same thing actually, but now you have to take note that the distribution that you are dealing with is t distribution, not z. Not z distribution. Okay, so 95% it sits in the middle. Okay, and the tail area is the total tail area is 5%. So you have to divide by 2. So each of the tail area is 0.025. Okay. So how to find the t value? Right, so now you have to find, you know the information of df, that is 5, the degree of freedom is 5, the tail area is 0.025, right, because you divide the 5% into 2. Okay, now let's go to the let's go to the t table. Okay, can you see the t table, my t table on the screen?
Yes, doctor.
Or you can refer to your own t table.
Yes.
Okay, you for your confirmation. Okay, so you know the degree of freedom is 5. This is the tell area. Remember, it's 0.025, right? And what you have to find out is the t value inside. So the t value is 2.571. This is the t value that you want to get. Okay, the tell area is 0.025. Okay, so 2.571. Okay, go back to my slide. Okay, remember 2.571, the t value. Okay, that's only there. Right. So you know that 2571, yeah, the t value. What you have to do next is you masuk dalam formula tadi. Okay, this one. The confidence interval for this t for this yang ada t, yeah. So this is x bar minus t sx, okay, x bar plus t sx for the upper limit, lower limit. It's actually the same thing like the previous case, but now you just substitute the t, and also the standard deviation is different, how you find out just now. Okay, so the lower limit is 366.67. Remember, this is the mean that you calculated from the sample. The t is 2.571. As the standard deviation just now is 60.97. Remember from the first step. Okay. And this one is lower limit minus. So the value is 209.904. The upper limit is plus. So you just plus the things. Yeah. But the values of the things here is similar, the t and sx. So it's 523.43 for the upper limit. Okay. And the final answer is you have to write the confidence interval where you have to put the mu in the middle. Remember, we are actually trying to give a picture about the population mean. So that's why we put mu over here, which is the mean of the population, not x bar. Okay. And the upper limit is 209.904. Upper limit, lower limit, upper limit is 523.43. Okay, so this is the final answer that you have to write. So it means that in this case, the researcher can be 95% sure that the mean reading of Tesla bandwidth, which is the population in this case, was between 209.904 and 523.43. Okay, if you don't write this last sentence, it's okay. As long as you put this range, this confidence interval. Okay? But you have to write this final answer, confidence interval, not just end up with the lower limit and upper limit. Okay, so this answers the question. So you can see that the trend is actually the same, right, for both situation when the standard deviation of the population is known and when standard deviation of the population is unknown, whereby you have to write this expression. Tapi apa yang beza is the how you calculate these values in the middle, the lower limit, upper limit ni kan. Whereby for this one you use t and the previous case you use z. Okay. So in order for you to not mistaken which table, so you make sure that you analyze the problem correctly. You actually can see from the question whether the standard deviation of the population is given or not. Okay, so that's the first thing that you have to figure out. Right, so these are the formulas that you have to use in this second case, right? This is the mean is somewhere here. This is the thing that you have to take note lah, the computation of the S standard deviation. So the standard deviation S ni, you have to use the formula I don't mention, formula ni. This formula that you have to remember to use. Some of the students might be stuck over here because they forgot to use this formula. So they would be like wondering how to find S then. So you have to remember by yourself. because in the exam, what will be given to you is a list of formulas. So we don't tell you that in this LU you have to use this, in this question you have to use this. No, so you have to decide by yourself. So please remember to use this formula. This is the one that we studied from the previous lecture, the formula. Okay, this is what you have to know, and then you find the SX. Yeah? Right, so just to summarize this step, okay? Calculate E, estimated standard deviation. Okay, you have to find this one first in order to find SX bar, find the degree of freedom. That one is n minus 1. Okay. Second step is to calculate the T. This is you look back at the question. What is the value of the confidence interval asked? It's 95%. You draw it. The same thing like how you draw for the Z, but this one is for T. So 95% is in the middle. 5% goes to the tail area. You divide by 2. So each of the tail is 0.025. Yeah, okay. Another common mistake is the student just take 0.05 and refer to the table. So that is wrong lah. Because if you refer to 0.05 tail area, it will give you different T. Okay, so you have to always remember that 0.05 you have to divide into 2 because there are 2 tails. Okay, and you only want to know you just refer to the one tail too bila you refer to the T table. So that's why it's the value of the T. Sorry, the information that you use when you find the T is 0.025, bukan 0.05. Yeah? So you get the T value. So once you get the T value from the table, you substitute into this expression because you want to find the confidence interval, right? So as X bar ni, you dah calculate from the first step just now. The T is the one that you substitute. So the expression is, the things here is the same, but what differentiates lower and upper limit is the minus and plus sign. Okay, so lower limit is this one. Okay, upper limit is this one. Okay, you calculate the lower limit, upper limit in the step 3. And the final step is to write the confidence interval. Okay, to write the confidence interval is this expression that you have to write. You have to masukkan lower and upper limit, and the value here is the mean of the population. Okay, the same thing goes for the second effort. For the first case, is always the mean of the population that we want to know that lies from what to what. Okay, so the same thing, like if let's say the question asks 99%, so it means that here the tail area will be different, and the T will be different as well. Okay, if it is 90%, it's different also. Okay, any question so far? So I don't want to go into too many things at one time because I want you to understand and then you practice. I will give you some exercises, extra exercises after this, but you have to do by yourself lah. I don't want to waste your data on online class. Okay, so any question before we wrap up? It's clear to you? So far so good. Okay, thank you. It's not that really much, right? I mean, it's you have a clear picture about what is what. Okay, so at the end of this lecture, you make sure you know what is confidence interval. It's always a range. Ingat confidence interval is always range. You have to come up with this expression tadi lah yang x mu is between what to what. Okay, confidence level. What is confidence level? We talk about it in the first slide, the first few slides. T distribution, okay, when to use the T distribution is when we compute confidence interval when the standard deviation of population is unknown. We use T, okay. In the first case, when the standard deviation of the population is known, we use normal distribution. Normal to get the Z value, put it into the upper and lower limit formula, okay. And the T here is for the lower and upper limit formula, okay. So that's what this lecture is all about. Right? It's basically about confidence interval and T distribution. Right. So this is just for you to get a picture where we are. Okay? We are under this part.